This is a really nice original question. We've got this number at the top, and it's the smallest number where if we take consecutive digits, none of the pairs make a prime number. So 12 is not, 24 is not, 45 is not, and so on. And then we're asked for the largest number that uses all the non-zero digits, such that none of the pairs make a prime number. So it kind of makes sense to start with 9 on the left, and we really want 9 on the left. We want to basically want to do our very best to get 8 on the left as well, and so on, and 1 on the right. But the question is, can we get away with this? And I think this is a good start to just see what happens. So 98 is okay, 87 is okay because that's divisible by 3 because the digit sum adds to 15, which is divisible by 3. 76 is even, 65 is fine, 54 is fine. Okay, when we get to 43, and that is not okay. So that is where an issue rises. Now, I've got to be honest, when I did this question, I kind of muddled through it a little bit, but a good pointer at this point is to think, well, what number ends in a 3 that is actually going to not be prime? Because lots of them are actually prime. 13 is prime, so we can't use that. 23. Okay, we can't obviously use 33 because it's not repeated. 43 we've already said. 53, no. 63 is okay. 73. So, I mean, at this point, like we've got to make it, we don't want to use any higher number, but 73 is prime, 83 is prime, 93 is not prime. So what this tells us, right, there's no way we want to put the 9 next to the 3 because it's going to be small, like we want to use the smallest one that we can. So basically, the upshot is that we're going to have to move the 6 further back. We're going to have to put the 6 next to the 3. So one thing to do would be to let's try and keep the 6 there and then move the 3 next to it. Is that going to be all right? Rather than moving the 6 over here, because then it'd be a 5, let's try and keep the 6 where it is. So 5, 4, and then we obviously skip the 3, 2, 1. Right, how is that? 98 is good, 87 is good, 76 is good, 63. Now 35 is fine. 54 is fine, 42 is fine, and 21 is okay. So that's got to be the answer. Um, we kind of, we saw that the problem lied with the 43. We found the number that ended in the 3 that wasn't prime. It's got to be the 6, but we want the 6 to be as far to the left as possible. So we moved the 3 there to make that one work. Okay, we have to have that working. And then if we follow it going down from then on, it also works. That's got to be the largest number. So what are the 5th and 6th digits? It's going to be 3 and 5. So an answer of E. Now I explained it like that was obvious, but I did muddle about with it. It took me a little bit more time to decide personally. That the 3 was the key thing. I was moving other ones around. I was messing with 42, 45, 46. I kind of didn't, I didn't hone straight in on the fact that it was the 43 that was the problem. So I needed to sort that 3 out. But in any case, there's different strategies, but that would be the quickest strategy, which gives us our answer of E.